Welcome again to Arxflix. Today, we'll dive into a fascinating paper titled Paint by Paint, Learning to Add Image Objects by Removing Them First. The research introduces an advanced method for adding objects to images via text condition diffusion models without user-provided masks. Here's a visual example of what their model can achieve. This is the final output after the object in painting model seamlessly adds new objects based on textual inputs. Let's break down the core concepts of this groundbreaking approach. Traditionally, adding objects in images is complex, requiring a deep understanding of image context, spatial alignment, and style consistency. Most solutions mandate users to provide detailed masks. This can be cumbersome, limiting practical applications. Researchers flipped the problem and discovered it's simpler to remove objects from images, a task known as in painting, thanks to segmentation mask datasets aiding the process. Inspired by this, the authors designed a pipeline to curate a large-scale image dataset. This dataset consists of image pairs, one with the object and one where the object is removed. They trained a diffusion model to inversely perform in painting by adding objects back. Take a look at this figure outlining how they build the pipe dataset. It showcases their VLM-LLM instruction generation process alongside the image in painting procedure, ensuring the curated dataset remains diverse and accurate. The dataset generation starts with object segmentation datasets like COCO and OpenImages. After selecting and refining masks, they remove objects using a stable diffusion in painting model. They further enhance the dataset by creating detailed natural language instructions for object addition using a vision language model, VLM, and a large language model, LLM. This leads to rich, diverse editing instructions representing real-world editing scenarios. Here, you can see some examples from the pipe dataset. This dataset contains over 1 million image pairs and more than 1,400 unique classes, providing a robust foundation for training and evaluation. To train the model, they used the pipe dataset and stable diffusion, conditioning the diffusion process on textual instructions and the input image itself for precise editing. This involved techniques like classifier-free guidance to ensure high-quality results. Their model underwent extensive evaluations against top-performing methods using quantitative metrics and human surveys. The results consistently show that their model outperforms others in adding realistic objects, maintaining high quality and semantic fidelity. These stages illustrate the filtering processes applied to ensure high-quality object removal and addition, targeting consistency and realism. Beyond object addition, the model trained on pipe can be combined with other editing datasets to enhance general image editing tasks. This demonstrates the model's versatility and robustness. This visual comparison highlights how their model surpasses leading editing models, maintaining fidelity to instructions and precise object addition. In summary, the Paint by Paint framework pioneers a novel approach for adding objects to images by leveraging in-painting techniques and advanced language models. The pipe dataset's scale and quality set a new benchmark, opening new horizons for image editing tasks. That's it for today's deep dive. If you're keen on exploring more about this research, do check out the full paper linked in the description below. Thanks for watching, and see you in the next episode on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.